In physics, motion is the phenomenon in which an object changes its position over time. Motion is mathematically described in terms of displacement, distance, velocity, acceleration, speed, and time. The motion of a body is observed by attaching a frame of reference to an observer and measuring the change in position of the body relative to the frame with change in time. The branch of physics describing the motion of objects without reference to its cause is kinematic. The branch studying forces and their effect on motion is dynamics. If an object is not changing relatively to a given frame of reference, the object is said to be at rest, motionless, immobile, stationary, or to have a constant or time invariant position with reference to its surroundings. As there is no absolute frame of reference, absolute motion cannot be determined. Thus, everything in the universe can be considered to be in motion. Motion applies to various physical system to object bodies, matter, particles, matter fields, radiation fields, radiation particles, curvature, and space-time. One can also speak of motion of images, shapes, and boundaries. So the term motion in general signifies a continuous change in the position or configuration of a physical system in a space. For example, one can talk about the motion of a wave or the motion of a quantum particle, where the configuration consists of probabilities of the wave or particle occupying specific positions. In physics, motion or of massive bodies is described through two related sets of laws of mechanics. Classical mechanics for superatomic, larger than atomic objects such as cars, projectiles, planet cells, and car humans, and quantum mechanics for atomic and subatomic objects such as helium, protons, and electrons. Historically, Newton and Euler formulated three laws of classical mechanics in an inertial reference frame. An object either remains at rest or continues to move at a constant velocity unless acted upon by a net force. In an inertial reference frame, the vector sum of the forces F on the object is equal to the mass m of the object multiplied by the acceleration a of the object is equal F is equal ma. If the resultant force F acting on a body or an object is not equal to 0, the body will have an acceleration which is in the same direction as the resultant. When one body exerts force on a body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. Classical mechanics is used for describing the motion of macroscopic objects from projectiles to parts of machinery as well as astronomical objects.